It's very easy to take for granted just how competent the human brain is when it comes to taking care of spatial. It's very easy to take for granted just how good the human brain is when it comes to controlling and manipulating objects. Take, for example, putting two halves of a ball together. Seems like a really simple thing that even a child can do, but when you're trying to get a machine to automatically do that, not quite so simple. So in this video, I'm gonna talk to you a little bit about the thought process that goes into solving a problem like this with robotics and automation. But before we get too far, leave a like, subscribe, comment, share, whatever. Anyway, back to the content. So, you have two halves of the ball, right? And we need to break down what does it take to actually put them together. Well, first of all, we need to be able to identify the two halves of the ball. So you can see that, hey, this one has a hole, this one doesn't. This one has a protrusion, and this one seems to receive that. So this is the male half of the ball, this is the female half of the ball. Hey, don't sue me, I didn't name it. But you can see that they go together like so. Alright, so we know that we've got two different things that we need to worry about. Next, how do we actually put them together once we identify what they are? Okay, we see that they are moving around, so we need to constrain the number of degrees of motion. Let's see about putting it face down. Okay, that's good. The reason we need to do this is because machines hate variation. Variation leads to problems, leads to machine crashes, and it's just not fun when you're dealing with robotics. So we need to constrain the variation as much as possible. For us humans, it's not a problem really, because I mean, just one finger, look how many degrees of motion, how much fine control I have. That's just one finger. We have 10 fingers and of course the rest of our body. And the brain is very good at calculating the motion paths, how much force is required, all of that. And that is great if you're a human, but if you're a machine, you don't have those advantages. In machines, they are very stiff. The degrees of motion are limited. So we need to perform this same task while severely constrained on how many degrees of motion we have to work with, because with machines, complexity means more points of failure. So the simpler you can implement a solution, the better. Otherwise, you're gonna have a situation where it's 3 in the morning, you're getting a call from a client saying, hey, we need you to come fix this now. So the less parts that can break, the better for you, the better for your clients, the better for everyone. Everybody wins, right? Okay, back to the problem. So when I'm resolving a problem like this, okay, reduce it down to its most basic steps. Step 1, constrain the motion, identify where they are. Step 2, it needs to be picked up, perhaps by a gripper of sorts or suction cups, but again, we have a hole here, so suction cups may not be ideal. I know that there's suction cups that can handle something like this, but I don't have a compressor in my lab, so we're not gonna go there. Pick it up, align it, put it together. So those are the basic steps that need to happen. Now that we know what we need to do, we just need to design a machine that does that. One key principle I like to follow is garbage in, garbage out. If you do not control and constrain whatever input, which in this case are these, from the very beginning, you have garbage input. Let's say your machine is expecting the two halves of the ball to arrive like this, but one of them arrives like this and one of them arrives like this. it's not gonna work very well, is it? I mean, they're not gonna stay together, are they? No, they're not. That was a trick question. Extra credit is after class. Back to it. So, yeah, automation engineers are problem solvers. There are a lot of problems that can be solved by boiling the task down to its core elements and then solving for each individual piece. You solve for how do we get it face down? Great, that's resolved. Next, how do we pick it up? Great, that's resolved. How do we align them? Great, that's resolved. How do we put them together? Great, that's resolved. And how do we deposit them where they need to go? So it's just a series of steps. It may look like a huge problem, a huge, overbearing, overwhelming task, but when you just do it bit by bit by bit, before you know it, you're gonna have a completed whole. And that's how I made this little puppy. Right over here. You can see there are cables everywhere. Don't call OSHA on me, this is still in development. And yeah, so anyway, if you like this format of video, let me know. I've been spending a lot of time making the robot and other various projects, so I haven't had as much time to dedicate to the channel. But I'm gonna just keep doing these. Hopefully, some aspiring engineers out there can learn a thing or two. Have a great day. Stay awesome. Stay blessed.